So in this video, we're gonna continue where we left off. So I believe I barely started question 12 when the previous video cut off. So we're gonna start from question 12. So the first three terms are given. So T1 is k plus 12, T2 is k, and T3 is equal to k minus 9. All right, so what is the value of k? So we know that T2 divided by T1, that is the common ratio. And T3 divided by T2 is also the common ratio. Basically, the nth term divided by the previous term gives me the common ratio. So therefore, T2 divided by T1 must be equal to T3 divided by T2. And now we can substitute our values. K divided by k plus 12 must be equal to k minus 9 divided by k. So this is the same idea that we have employed in our previous video. So now, if I take k here, if I multiply by k on both sides, I have k squared divided by k plus 12 equal to k minus 9. And if I multiply k plus 12 on both sides, I get k squared is equal to k minus 9 times k plus 12. Alright, so k squared is, if I expand this out, I get k squared plus 12k minus 9k is plus 3k minus 12 times 9. So you can use your 12 times 9 is, I believe, 12 5s is 60, 12 6 is 72, 12 7 is 84, 12 8 is 96, 12 9 is a negative 108, I believe. Yep, negative 108. And now you can subtract x squared from both sides. Sorry about that. So you get 3k is equal to 108. And k is equal to 108 divided by 3. That is 336. All right. So now the value of k is just 36. So let me just check it for you. 12a, yes, it is 36. And find the sum to infinity. So we know T1, we know R, so we just need a, which is T1, is k plus 12. 36 plus 12 is 48. So the sum to infinity is just going to be a divided by 1 minus r. So that is 48 divided by, so I just substituted 36 here to get my first term. So that is 48 divided by 1 minus, what is the common ratio? Well, the common ratio is this expression. So T2, which is k, is 36, divided by 48, which is T1, must be my common ratio, right? So that is 3 over 4, I believe. So 1 minus 3 over 4. And that is just, and if you simplify, you get 48 times 4, which is 192. So your answer, the sum to infinity must be 192. So this is your answer. So I left out some of the simplifications because I believe we have done enough algebra for you to figure out, for you to get to 192. All right, question 13. The fourth term of a geometric progression is 48. So T4, which is AR cubed, remember it's T4 is AR to the power n minus 1, and 4 minus 1 gives me 3. So AR cubed is 48, and the sum to infinity is 5 times the first term. So 5a, right? Sum to infinity is given to be 5a. All right, so I know sum to infinity is just a over 1 minus r is equal to 5a. And for a non-zero a, I can divide by a on both sides. So I get 1 over 1 minus r is equal to 5. And if I multiply by 1 minus r on both sides, I get 5 minus 5r. So what I did, I just multiplied by 1 minus r on both sides, and these cancelled out. So, and on the right-hand side, I get 5 minus 5r. So minus 4, if I subtract 5 on both sides, I get minus 4 is equal to minus 5r, and therefore r is equal to 0.8, or 4 over 5. Whichever you prefer. So now we know r. We can solve for a here. If we know r, we can solve for a. So we know a times 0.8 cubed is 48. So a is just going to be 48 divided by 0.8 cubed. So that is 48 divided by 0.8 cubed gives me, I'm so sorry, let me do that again. 48 divided by 0.8 cubed gives me 93.75. So that is 93.75. So that is going to be your answer for 13. All right. Question 14. A geometric progression has a first term a, so t1 is a, and a common ratio r. The very standard things. The sum of the first three terms is 3.92. So a plus ar plus ar squared. That is my first term, my second term, my third term. So sum of, this is S3, is given to be 3.92. And the sum to infinity is 5. So a over 1 minus r is equal to 5. So I can actually write a in terms of r, right? So we want to find the value of a and the value of r. All right. Another way to write the sum of three terms is going to be another way. So I'm going to keep this here. And this is just sum to infinity, right? So I know the relationship between a and r. Now another way to write S3 is equal to a, and we have three terms, so r cubed minus 1 divided by r minus 1. So if you simplify, you actually get this, so we'll not be using this form. All right, so I know that a is equal to 5 minus 5r, right? If I multiply by this on both sides. And I can substitute this expression. So I have 5 minus 5r plus 5 minus 5r times r plus 5 minus 5r times r squared is 3.92. And now, if I simplify, I get 5 minus 5r from my first term plus 5r minus 5r squared from my second term. And for my third term, I get 5r squared minus 5r cubed. And that is 3.92. So let me take this a bit further so that you don't get confused. Sorry about that. All right, so minus 5r and minus 5r get cancelled. Minus 5r plus minus 5r squared plus 5r squared get cancelled. So I have 5 minus 5r cubed is 3.92. So minus 5r cubed, if I subtract 5 on both sides, is negative 1.08. So I just subtracted 5 on both sides. So 5 minus 5 will give me 0, right? Or actually, minus 5 plus 5 will give me 0. And now, if I cancel out the negative signs, I get r cubed is 1.08 divided by 5. And therefore, if you take this expression and raise it to 1/3 power, or you take the cube root, you get r is equal to 0.6. So we know the value of r, which is 0.6, and using this we can calculate a. So a is just 5 minus 5 times 0.6. And that gives us a is equal to 2. So we have 0.6, so this is 3 by 5, and a 2. So that is your answer. All right, so question 15. The first term of geometric progression, a is equal to 1, and the second term is 2 cosine x. So you know that t2, which is equal to ar, is equal to 2 cosine x, and we know the value of a. A is just 1. So therefore, r is equal to 2 cosine x. And find the set of values of x for which this progression is convergent. So the condition for convergence is that modulus of r is less than 1, right? Or another way of writing this is just negative 1 is smaller than r, which is smaller than 1. So that is our condition. Now we just substitute our r value, 2 cosine x less than 1. And therefore, negative 1 by 2, if I divide by 2 everywhere, I get cosine x less than 1 by 2. So since 2 is positive, I don't have to worry about switching my inequality signs. So now we have to think about the cosine graph. So if I roughly draw it out for you, the cosine graph looks something like this. So it starts at positive 1 and it's an even function. So an even function means it's symmetrical about your vertical axes. So it goes like this. Let me redraw it. So something like goes down and comes back up like this on both sides. So come back up, something like this. And this is going to be negative 1. So it goes from 1 to negative 1. I know the drawing is like not very correct to proportion, but I hope it helps. So this point and this point, so it hits 0 at pi by 2 and negative pi by 2. So those are the zeros. At 90 degrees and negative 90, cosine x is 0. This is 0, but we need to find out when it's pi. So if you think about it, when is it, at what angle is cosine x half? Well, we know that cosine 60 degrees is equal to half, right? And 60 degrees in radians is pi by 3. So therefore, our angle x must be less. So if we want it to be less than 1/2, right? So our angle x must be less than pi by 3. If it's less than 60, then it's less than half. Sorry. If my x is bigger, so let's look at here. 60 degrees is somewhere over 60 degrees, and this is 90 degrees. Pi by 2 is 90, right? So let's say this is 60 degrees. Anything less than 60 degrees, if I have anything less than 60 degrees, which corresponds to these values, then it's bigger than half. It's towards -1. So I need my angle to be bigger than 60. So my angle x, which is the argument for my cosine function, is bigger than pi by 3. And let's see. So we are given this range. Find the set of values for which this progression is convergent. All right. So x has to be bigger than pi by 3, which satisfies the condition that x is less than pi by 3. So we don't have to worry about that because we are only limited to the first quadrant, right? So in the first quadrant, which is from 0 degrees to pi by 2 degrees, then our cosine value only goes from 0. So our cosine x is always going to be bigger than or equal to 0. So, so we don't have to worry about -1/2. We don't have to worry about this because we are limited to the first quadrant and all our output values are going to be positive. All right. So our angle has to be less than pi by 3, and our angle has to be bigger than pi by 3, and because we don't want negative output, we don't want our common ratio to be negative, we are restricted by this. So it has to be less than pi by 2. This is the condition for convergence. Otherwise, we could have gone up until this point. So anywhere between this, because r can be negative as well, anywhere between this 60 and this lower point where it's -1/2, it would have been convergent, but we're restricted in the first quadrant. So this has to be your answer. So I hope that explanation was satisfactory, although I know I got stuck a bit and might have come off as very poor. But the idea is you want to draw the graph out, and you notice that if at cosine 60 degrees, it's half, which is 0.5, and if at cosine, so 60, in the second quadrant, cosine is negative, so I think at 120, right? At 120 degrees, it's also, so cosine 120 degrees is -1/2. So as long as your angle is between these, it's in between -1/2. So your cosine of that angle is between -1/2 and +1/2. But because we're restricted in the first quadrant, so our angle has to be less than 90 degrees, pi by 2, but it has to be bigger than 60. So it has to fall in this range for r to be less than, for the condition to be satisfied, for the series to converge. And all right, that is the answer for 15. So I hope this helps. I hope please feel free to replay the video so that you understand the explanation better. I do realize it was a bit poor, but hopefully the correction helps. And yeah, so basically in the next video we're gonna skip over question 16 and 17 for now. So we're gonna do arithmetic and geometric mean, and we'll come back to this. I'll upload a part 3 in the near future.